Good morning, calculus students. So Mr. Chen again. So today I would like to talk about that one of the unit. Believe this one is chapter 8, part of the 8.1, 8.2. It's about the arc length and the surface of revolution. So let's start it all with the arc length. And you guys may be wondering the way to find out the arc length back to trigonometry. The formula for that, it's about the circumference multiplied by the ratios. So the circumference of a circle multiplied by the ratio. So we call that, so this one is considered r times theta, which r is the radius, and theta it's a central angle in terms of radian. So imagine that you have an ant, it's walking along the curve from point A to point B. Okay, so it's going this way from point A to point B, like that. Okay, so if we try to connect all those line segments here, so this one will be considered the arc length. So how far did the ant travel? So, and we can use the distance formula to find out. Okay, so the distance formula, which is based on geometry, so square root of x2 minus x1 quantity square plus y2 minus y1 quantity square. So if that's just a segment, if that's just like linear, so we can apply that to distance formula from point A to point B. But this one, it's not just about the straight line segment, it's about the arc length, because the ant doesn't go through like straight like this. So it's all about the arc length. So the way to do it, so this one, it's all about using the differentials. Okay, so the differential, as you can see that right here. So this one, it's all about getting the distance of each positions. So once you integrate it from point A to point B, so we'll get the arc length. So if you just compare that, the integrand along with the distance formula, so this one is quite similar to each other. So y2 minus y1 quantity square, so you can say that this one would be considered the differential. Okay, so the differential. So let's say that this one, it would try to divide both sides by x2 minus x1 quantity square. And then over here, divided by x2 minus x1 quantity square inside. Okay, inside the radical. So basically this one will give you the similar situation. So this one is kind of like the average rate of change with the quantity square. So it's the instantaneous rate of change, quantity square. So once you divide this whole thing, so that would be considered 1. Okay, so again, the square root, we want to extend it all the way through. Another way you can think about it, so distance, this one is just considered square root of delta x squared, because x2 minus x1 is just the change of x value. And this one, y2 plus y1, is just considered delta y quantity square. Okay, so delta y quantity square. So, and then delta x, delta y, this one is just like a partial distance. So in order to get that, all the distance, so you want to integrate it from point A to point B. So this one is just a partial distance, square root of delta x quantity square plus delta y quantity square. Okay, so now, check it out, one of the examples that we have right here. So find the arc length of the graph. So y equals x to the power of 3 over 6 plus 1 over 2x on the interval. So using that formula, so what we found here, so let's start it off with f of x. So that would be x to the power of 3 over 6 plus 1 over 2 times 1 over x. And then f prime of x, differentiate it, so 3 over 6, which is 1/2, x squared, and then this one 1/2 times negative 1 over x squared. And then with that, the derivative, so basically we can just set up the equations, the formula for the arc length. So arc length, integral from 1/2 all the way to 2, so square root of 1 plus the quantity of 1/2 x squared minus 1/2 1 over x squared quantity square, okay, times dx. So now you want to integrate it from here. So this one, it's going to be a lot of those type of work that you need to show. Expansion, simplifying. So that's what I'm going to show you on one of those pages. Okay, so let me just pause something here real quick. Okay, let me just snip this one, because this one's going to be a lot of work in order to do manually. Okay, so let me put into the active inspire. Okay, let me go back to the screen here real quick. Okay, so where's my active inspire? Okay, let's just open it up. Okay, so anytime that you try to do the integral with the radical like that, so normally we can apply the formula, but this one it doesn't show any kind of special formula. You guys might be wondering about the inverse of trig function. Probably it's not. Okay, so this one, okay, let me open it up, this one. Okay, so now for the bracket, so things that we can simplify, we want to expand things out. So we do have 1/2 x squared minus 1/2 times 1/x squared, quantity squared. So using the binomial expansion, so what we found here is square root of 1 plus 1/4x quantity to the power of 4 minus 1/2 plus 1/4x squared. Well, this one can be done by using the FOIL method if you want to do that. And then for the radicand, so what I can do with the radicand here, so before we integrate it, so it looks like we can combine the like terms, so 1 minus 1/2, which is 1/2, and then plus 1/4x to the power of 4 plus 1/4x to the power of 4. And then for the rest of this, we want to take out the greatest common factor, which is 1/4. It's kind of tedious. We have to put in the integral with the limit, the boundary, a and b all the time. So take out 1/4. So we do have x to the power of 4 plus 1/x to the power of 4 plus 2. And you might be wondering, what about this kind of weird trinomial? So definitely we can factor it out. So you try to factor it using the smiley face. So x squared, x squared. So 2, this one, well, let's just swap that 2 and 1/x to the power of 4. So swap those two terms. So 2 plus 1/x to the power of 4. So we do have 1/x squared, 1/x squared. So once you multiply this with the smiley face method, you'll see that the sum of the product of those factors is going to be 2. So that means this one can be written as a perfect square form. So square root of 1/4. So times x squared plus 1/x squared, quantity squared. And then with the radical, so this one, everything turns out to be straightforward now. And what we can do, so cancel out the radical, so reduce that 1/4 to 1/2. So 1/2 to 2, so it's 1/2. Quantity square, square root, so that means the exponent, the radicals got cancelled, so we do have quantity of x squared plus 1/x squared. And then the rest of this, so now you want to distribute, so we got 1/2 x squared, and this one right here, so that turns out to be 1/2 1/x squared, from 1/2 to 2. So integrate it, so this one turns out to be x to the power of 3 over 6, and then this one is 1/2 times 1/x, and then this one, well, it's negative 1/x. So this one, it goes all the way from 1/2 to 2. So f of b minus f of a, so 2 cubed over 6 plus 1/2 times negative 1/2. Okay, so this part right here is f of b minus f of a, and then 1/2 to the power of 3 over 6 plus 1 half. Negative 1 over 1 half, then that'd be negative 2. Okay, so this part right here, f of a. So the rest of that is just pre-algebra, so simplifying it using PEMDAS, so 2 to the power of 3, 8, a over 6, which is 4/3. 1 half times negative 1 half minus 1/4. Okay, minus, this one's 1 half to the power of 3, 1/8, divided by 6, so 1 over 48. Negative 1 is subtracting the whole quantity. So distribute, so we do have 4/3 minus 1/4, and then minus 1 over 48 plus 1. Combine them, so 4/3 plus 1, so we do have 7 over 3 minus 1/4 minus 1 over 48. So the least common denominator, which is 48. Okay, let's put it right here. So 3 times 16, so that'll be 48. So 7 times 16, so 7 times 6, 42. 1 times 7 plus 4, 112. Minus 48, 12 over 48, minus 1 over 48. So the answer is going to be 99 over 48. And then this number divided by 3, so we do have 33 over 16. So then that would be the arc length. Okay. So now going back to the page, the one that we started with, the template right here. So this one is 33 over 16. You can always check the work on the calculator, just typing that y1 and then integrate it from 1 half to 2. Okay, so here's another one. So this one you want to try. Find the arc length of the graph. So again, this setup. So started off with y prime. So the y prime, which is 1 over cosine of x, using the chain rule. Derivative of cosine, negative sine. So this one turns out to be negative tangent of x. And then using the arc length formula, so integral from 0 to pi over 4, square root of 1 plus y prime quantity square, so negative tangent of x quantity square. Okay, so making sure that we follow through the formula and also the indicator, dx. Okay, so the formula right there. Okay, so 1 plus tangent square of x, so that's exactly as secant square of x, using the Pythagorean identity. So square root of secant of square of x, then that would be secant of x. Okay, so you might be wondering, what's the integrals of secant of x? And integrals of secant of x would be natural log of absolute value, secant of x plus tangent of x. And it goes all the way from 0 to pi over 4. So plugging a number, so natural log of secant of pi over 4 plus tangent of pi over 4 minus natural log of secant of 0 plus tangent of 0. So secant of pi over 4, which is root 2, tangent of pi over 4, which is 1. So natural log of this quantity with the absolute value, minus natural log of secant of 0, which is 1, tangent of 0, which is 0. So natural log of 1, that's 0, so this one is cancelled. So the final answer, natural log of absolute value of root 2 plus 1. Now you might be wondering, can we expand it? No, we cannot, because this one is a sum, it's not a product. Okay, so there's no such property for the natural log. So that would be the arc length. Okay, so thank you for watching the video today. So in case I do have any questions, so please refresh, just go back to the beginning of the video, or just watch the part of the lesson that you feel you need more emphasize or more review. Okay, so I'll see you guys next time. You guys have a great one. Take care.